Hello everyone, I am Saurabh and I welcome you back to the Digital Board series by Orchids Biosciences. This is the second video for the chapter, Our Environment. If you haven't watched the first video yet, I have provided its link in the description below, so please do look for it and watch it. In this video, we are going to discuss the following topics. We will start with the concept of food chain, then discuss about its various trophic levels. After that, we will discuss about the food web. Then we will also discuss what is biological magnification or biomagnification. Then we will discuss how our activities affect the environment, in which we will discuss the ozone layer and its depletion. And finally, some methods to manage the garbage we produce. So let's begin with the food chain. In the previous video, we have discussed about the ecosystem, and we know that ecosystem is made up of abiotic as well as biotic components. The biotic components are the living organisms which can be classified as producers, consumers and decomposers. The consumers can be further classified as herbivores, carnivores, omnivores and parasites based on their feeding habits. So we know that ecosystem is basically a variety of living organisms along with the abiotic factors. Now let us consider an ecosystem with these living organisms. We have plants, grasshoppers, frogs and snakes. There will be different abiotic components also. But now to understand the food chain, we are considering these organisms. Now if we look at these organisms, one organism will be dependent on another organism for their food. For example, the grasshopper will be consuming the grass or the plant. The frog will be consuming the grasshopper. The snake will be consuming the frog. So one organism is dependent on another organism for their food. So there is a transfer of food energy from one organism to another. So in this chain, there is a transfer of food energy from one organism to another. And if you notice, they are sequentially interlinked. So there is a sequential interlinking of various organisms. Where it is starting from the producer level. We know that the grass, that is the plant, is at the producer level because the plant will be trapping the light energy from the sun and producing its own food. Now this grass will be consumed by the grasshopper, and like this the food energy goes higher. So this producer will be consumed by another organism. Then this organism will be consumed by another organism. And another interesting fact here is, one organism is consuming an organism as well as is being eaten by another organism. For example, the frog is consuming the grasshopper as well as is being eaten by the snake. So it is consuming as well as is consumed by another organism. So here it is consuming and here it is being consumed by another organism. So now we have an idea what is happening here. So the sequential interlinking of organisms which involve the transfer of food energy from the producers through a series of organisms that consume and are consumed is referred to as food chain. So this is our food chain, and this is an example of terrestrial food chain. So this is a very simple example to understand food chain. The very most important thing which is happening in this food chain is there is a transfer of food energy from one level to another, from one organism to another. And if we see, there are various levels or various steps in a food chain. So these various steps or various levels in food chain are called as trophic levels. So there will be various trophic levels. This is first trophic level, this is second trophic level, this is third trophic level, this is fourth trophic level. So if we see at the first trophic level, what comes are the producers. At the next trophic level, there will be primary consumers. Then at the third trophic level, there will be secondary consumers. And at the fourth trophic level, there will be tertiary consumers. At the producer level, we have generally the autotrophs, the plants. At the primary consumer level or at the second trophic level, we will be basically having the herbivores, the organisms which feed on plants. There can be omnivores as well. It is all depending upon the organisms which are present in that specific ecosystem. Then these herbivores which are present at the primary consumer level or at the second trophic level will be consumed by the small carnivores. That is the frog. Then these smaller carnivores will be consumed by the larger carnivores. So this is with respect to these organisms which I have explained. There can be various other food chains as well. So autotrophs or the producers come at the first trophic level. Herbivores or the primary consumers come at the second trophic level. Small carnivores or the secondary consumers come at the third trophic level. Larger carnivores or the tertiary consumers come at the fourth trophic level. Now, why are we discussing only up to fourth trophic level? Let me explain. Now, if we look at the producers, this will be able to prepare its own food. So let us imagine it takes the energy from the sunlight. So how much amount of energy will it take from the sunlight? It will take approximately 1% of the energy from the sunlight and prepare its food. So let us imagine it prepares its food and the amount of energy available at first trophic level is 10,000 joules. Now this energy will be used by that organism itself or the organisms at that level itself. Why? Because the plant will be requiring this energy for growth, reproduction and various other processes. So out of this 10,000 joules, out of the amount of energy which is present at the producer level, only a 10% of the energy approximately will be going to the next trophic level. So how much of the energy from 10,000 joules will be going to the next trophic level? Only 1000 joules will be available at the second trophic level. Now again, here the grasshopper will be using the energy for its digestion, growth, reproduction and other processes. So only again a 10% of energy will be going to the next trophic level. So again 10% of 1000 will be only going, that is only 100 joules of energy will be going to the third trophic level. Now when we reach the fourth trophic level, the amount of energy which will be available, amount of usable energy which will be available will be only 10 joules, because 10% of 100 is 10. So as we move higher up in the trophic levels, the amount of usable energy will reduce. So by the time we reach the fourth trophic level, the amount of usable energy left will be very less. So generally a food chain will be limited to 3 to 4 trophic levels only, because of this 10% flow of energy from one trophic level to another, and this is called as the 10% law. And one more thing if we notice is, at the producer level, the number of individuals will be much higher when compared to the individuals at tertiary consumer level or at the fourth trophic level. If we see in this pyramid, the number of individuals at the producer level is the highest. There will be highest number of individuals at the producer level, whereas the number of individuals in the tertiary consumer level or in the fourth trophic level will be the least. So as we go higher up from first trophic level to the fourth trophic level, the amount of usable energy also will reduce, as well as the number of organisms in that specific trophic level will also reduce. So that is why the pyramid is formed. That is, highest will be at the base, that is at the producer or at the first trophic level, and the least will be at the fourth trophic level or the tertiary consumer level. And once an organism is eating another organism, for example, the energy is transferring from the producer level to the next level. This energy cannot be transferred back to the producer level. For example, from this level, the energy is going to this level. So the energy is being transferred. It is only unidirectional. This energy cannot come back. This is not possible. It is only one directional flow of energy. Similarly, now from the second trophic level, that is from the grasshopper, the energy is going to the frog. So here also the energy flow is unidirectional. The energy can flow only from grasshopper to the frog. This energy cannot come back from the third trophic level to second trophic level. Now if we look at the first trophic level itself, the energy which is coming from the sunlight is also unidirectional. The light energy which is coming from the sun will be utilized by this producer or will be utilized by the first trophic level and cannot go back to the sun. So therefore there is a one directional flow of energy, or there is unidirectional flow of energy in a food chain. So this is about a complete description about the food chain. Now, this is not only going to be the case in every ecosystem. For example, now in this ecosystem, there are other organisms as well. Let us consider there is a deer, a lizard, fox and a lion. Now, what will happen? What will be the case? We know that the deer is a herbivore. So, this will be eating this plant. Now, the deer will be eaten up by this lion. Which organism can this lizard feed on? The lizard can feed on this grasshopper. So, the grasshopper will be consumed by this lizard, and in turn consumed by or eaten up by the fox. So again, if we see, there is some interlinking being formed here. So this alone can form a food chain: grass, deer and lion. For a 3 trophic level food chain, this itself can act as a food chain. Or else another food chain can be formed: grass, grasshopper, lizard and fox. A 4 trophic level food chain can be again formed. Now this all food chains can also be interlinked. Now how can it happen? What if this lizard is being eaten by the snake, or this frog is being eaten by this fox, or the fox is being eaten by this lion? So there are 3 different food chains which we got now. But now there is an interlinking between this food chain itself, or we can say there is an interconnection between the food chains itself, and this is called as a food web. So what is happening here? instead of a straight line food chain which we were getting now, we are getting a branched connection or a multiple interconnections of food chain we are getting now, and this is referred to as the food web. So how can we define food web? The interconnected food chains which establish a network of relationships between various organisms in an ecosystem is called as a food web. So if we see, there is an interconnection of various food chains here, and they are establishing a network of connections between various organisms, or we can say there is a network of relationships. What relationship it is? It is based on the feeding relationships between organisms in an ecosystem. This will be called as a food web. The interconnected food chains which establish a network of relationship between different organisms in an ecosystem. So this is a very detailed explanation of food chain, what are the trophic levels, what is food web. And let us look at another interesting aspect of food chain, that is biological magnification or biomagnification. So what is this biological magnification, biomagnification? It is interesting to know that even though we do not go and eat any harmful chemical substances which are called as toxicants. Toxicants are the toxic substances in our body. So even though we don't go and eat them directly, how do this toxicant enter our body? They enter our body because of the food chain. How did it enter the food chain? Let us see. We know that there are several chemical pesticides or various other chemicals which are used in the crop field to increase their productivity. For example, DDT. This is a very common pesticide. So this DDT pesticide is used in the crop fields. Now this DDT or any other chemical pesticide can be either washed down into the soil or the water bodies like lakes, river, ponds, whatever. Now if this is entering the soil or water bodies, from the soil this can be taken up by the plants. Why? Because if it is present in the soil along with the water and minerals when the plant is absorbing, this DDT or any other chemical pesticide can enter the plants. Similarly, if it is present in the water bodies also, the aquatic plants can take up this DDT. So now we can see it has entered our food chain at the producer level. So if it is present at the producer level, definitely it can reach the highest level of food chain, that is human beings. So by the time it reaches human beings, the amount of toxicant which was present in plant will increase so much when it reaches the human being level or the fourth trophic level. We will see how it happens. So plants are present which is at the first trophic level. This will be eaten by a primary consumer. This will be eaten by a secondary consumer. This will be eaten by the human being, that is at the fourth trophic level or acts as a tertiary consumer. Similarly, from the aquatic plants, it can go to the aquatic organisms. And from the aquatic organisms, when human beings eat them, it can even enter like this. We'll take the example of terrestrial food chain itself, understand. That is from plant how it gets. Even for the water bodies, the case will be same. Now let us imagine the plant has some X amount of DDT which it has absorbed from the soil. Now when it goes to the primary consumer level, the value of X will increase. The amount of the DDT in the primary consumer level will be higher. Now when it enters the secondary consumer level, it will increase further. And finally by the time it reaches the human being, it will increase to a much greater extent when compared to plants. Now we know that there is only 10% flow of energy, but why is there an increase in the DDT level? Why is it not reducing? Instead of reducing, it is increasing at every successive trophic levels. A very simple reason for that is a primary consumer will not eat only one plant. Now for example, a primary consumer eats 2 plants. So the amount of DDT at the primary level will be X plus X, because 2 plants it is eating, it will be having 2X amount of DDT. Now this secondary consumer will not be having only one primary consumer in its entire life. Maybe it will have 5 primary consumers. So 5 into 2, 10X amount of the DDT will be here. Now human beings of course will not be eating only one animal in its lifetime. He will definitely not be eating only one secondary consumer. At least 10 secondary consumers will be eating. So 10 into 10, 100x. So the amount of DDT is becoming 100 times what it was present in plant. So this is just a representation to explain why the amount of DDT or the amount of chemical pesticide will be higher at higher trophic levels. So biological magnification can be defined as an increase in concentration of toxicants at successive trophic levels. So from one trophic level to another, which means at successive trophic levels, we can see there is an increase in the concentration. So this is about biological magnification. Now let us learn about how our activities will affect the environment. We human beings or any other organisms are a very integral part of the environment. If there is any change in the environment, it is definitely going to affect us. And our activities will also affect the environment. So if one is also harmed, the effect will be seen on another. So if we are harming the environment, it is indirectly or directly going to affect us. So let us understand this. To understand, we will study ozone layer and its depletion. Now what is this ozone layer? Ozone layer is present in our stratosphere, which is made up of ozone molecules. What is ozone? O3 molecules. We know O2, that is molecular oxygen. From this molecular oxygen only this O3 molecule is made. How it is made we will discuss now. Ozone is a deadly poison. However, at higher levels of the atmosphere, it will shield the surface of the earth. So this is acting as a shield for our earth. But if it is present among us, this is going to act as a deadly poison for us. We will not be able to survive. But at the higher levels of the atmosphere, it is going to act as a shield for the earth. How it is going to act as a shield? This ozone will block any kind of entry of ultraviolet rays. Now, why is it blocking the ultraviolet rays? Is it going to affect us? Yes, it is going to affect us. The ultraviolet rays are known to cause skin cancer in human beings. So this ultraviolet rays can cause cancer in human beings. So if ozone is present at this higher levels of atmosphere, will be blocking the entry of this UV rays. So if ozone layer is present, only this UV rays will be blocked. If this ozone layer is not present, the UV rays will not be blocked and it will enter into our atmosphere and will penetrate our skin. And if it penetrates our skin, it is known to cause cancer. So now, if we affect this ozone layer, then it is definitely going to affect us. So affecting the ozone layer will have an impact on us. So this is what I was telling. If we harm the environment, it is going to harm us in return. If we harm the ozone layer, then the ozone layer will not be there and in turn we will be harmed. Because if the ozone layer is not there, it will no more be protecting us from this UV radiations. And this UV radiation will come into our atmosphere and is known to cause cancer. Now let us discuss about ozone layer in detail. This ozone layer, as I have said, is O3. How is this O3 formed? At higher levels, what will happen is this UV radiations will break down this molecular oxygen into free oxygen. So O2 will break into O plus O. Now this oxygen will combine with the molecular oxygen. So molecular oxygen will also be present. So this O will combine with this to form O3. Once again I repeat, the O2 molecule, that is our normal molecular oxygen which we breathe. This, by the action of UV rays, will be broken into two free oxygens. Now one of this oxygen will combine with the normal O2, that is normal molecular oxygen molecule, to form the O3 molecule. So this is how the ozone is formed, or O3 is formed. And this O3 is very important to shield or protect our earth from this harmful ultraviolet rays. Now how are we affecting the ozone layer? The production of CFCs, that is chlorofluorocarbons. The production of the CFCs are the reason for the degradation of ozone layer, or we can say the depletion of ozone layer. What is depletion? Depletion means thinning of ozone layer. Ozone is not just one single layer, there will be many layers of ozone. So by the production of CFCs, or if the CFCs are left in the atmosphere, then what it is going to do is the CFCs are going to affect the ozone layer. It will cause a thinning of the ozone layer, which is called as ozone depletion or ozone layer depletion. If we produce more CFCs, then the ozone layer will become thinner and thinner, and at the end the UV rays will start coming inside. It will not be able to block the UV rays. So we should not use the chlorofluorocarbons. In the 1980s, it was observed that the amount of ozone in the atmosphere began to drop sharply in the 1980s. This decrease in the ozone has been linked with this CFCs. These CFCs are synthetic chemicals. So what happened was, 1987. In 1987, United Nations Environment Programme UNEP succeeded in forging an agreement to stop or to freeze the CFC production at the 1986 level. So whatever was the CFC production at 1986 level itself, they forged an agreement to stop or freeze it at that level itself. In which year did this happen? In 1987. So in 1987, finally, the United Nations Environment Program, UNEP, finally succeeded in forging an agreement to freeze or stop the CFC production at 1986 level. So whatever was the level of CFCs in the 1986, at that level itself, they were asked to stop so that there is no more further increase in the CFC levels. Because if further CFC levels increase, then there will be again harm to the ozone layer. So this is what we have seen, that how affecting the environment, that is the ozone layer, will affect us in return. Because if ozone is not there, UV will come in and we might be prone to cancer. So moving on to the last topic for this chapter, that is managing the garbage we produce. So what is garbage? The household wastes are commonly referred to as garbage. So what are the household wastes which we generate? They can be plastics, there can be papers, there can be metal items, there can be many biodegradable wastes. For example, fruit peels, vegetable cutouts, onion peel, etc. So there are different varieties of waste which we can produce. So all these household waste can be commonly referred to as garbage. Now we are going to learn the methods of managing the waste, or we can say the management of garbage. Garbage is basically what? It is basically household waste. So we can say it as garbage management or waste management. We are going to learn 4 methods for waste management. Let us look at them one by one. First method is recycling. Recycling is a very common method. In recycling, we take any unuseful or waste material and we convert it into something useful, or we can make something new out of it. So taking a waste material and making something new out of it is called as recycling. For example, we can recycle old papers to get new sheets of paper. We can take all old glass bottles and make new something out of those glass. We can take old plastic or tins and recycle them. So the waste materials can be made into something new which can be useful to us. So this is about recycling. This is one type of waste management. Next type of waste management is composting. This is very interesting. But the problem with composting is you cannot do it with non-biodegradable substances like in recycling. In recycling, we can take non-biodegradable substances. But here in composting, we can take only biodegradable substances. So what is this composting? In composting, what we do is we take this organic waste which is being produced by various households, and all this organic waste, we are putting it under the soil. Now when we put all this organic material under the soil, by the action of various microorganisms, the process of decomposition takes place. And all this biodegradable waste is now decomposed and made into a nutrient-rich manure. This nutrient-rich manure is very, very beneficial for the plants. So if we see all this biodegradable waste, we take and put it under the soil so that it later becomes into manure for the plants. So this will be very much nutrient-rich and is very, very beneficial to the plants. So this is composting. Next, third method which we will be studying is landfilling. The name itself suggests what happens in this. In this, we fill the garbage into the land. So we will be filling one layer of garbage, then we will be putting one layer of soil, then another layer of garbage, then we will be putting another layer of soil. So garbage, soil will be put like that. So the garbage will be spread like a thin film, and then above that soil will be put. Again above that another layer of garbage, above that another layer of soil. So we are filling the land with the garbage. So this is called as land filling. This is the third method of waste management. Moving on to the next method, that is incineration, which is also called as burning or combustion. So what we do, as the name suggests, we are going to take all the waste materials and burn it. So in burning, what happens is most of the waste materials will not be there. So if, for example, 100% of waste was there, it will be reduced to only 10% in the form of ashes and fumes. But the problem with burning is that it will produce a lot of environmental problems. So this is not environmental friendly. Whereas composting, recycling, these are very much environment friendly options. Burning, combustion or incineration is not that of an environment friendly option. But when we are releasing these fumes into the atmosphere, we have to be very clear that we purify these fumes before it reaches the atmosphere, or it may cause damage to our environment. So this is the fourth method, that is incineration. So these are few methods of waste management. So with this we come to the end of this chapter. Let us quickly recall what we have seen in this video. We started with what is a food chain. We know that food chain is a sequential interlinking of organisms which involves the transfer of food energy from the producers through a series of organisms that consume and are consumed. So this is referred to as the food chain. Next we discussed about trophic levels. What are trophic levels? The various steps or levels of the food chains are called as trophic levels. In a food chain there are basically 3 to 4 trophic levels, because after 4th trophic level the amount of usable energy that will be left over will be very less. And one more thing which we discussed was the flow will be unidirectional. The flow of energy in a food chain will be unidirectional, or flow of energy from one trophic level to another trophic level is unidirectional. And the amount of organisms or individuals at lower trophic level will be higher when compared to higher trophic level. So amount of individuals also as well as energy also. At lower trophic level will be higher, at higher trophic level it will be lower. This is what we have already seen. Next we discuss about food web. We know how food web is formed. Food web is formed by the interconnection of various food chains which establish a network of relationship between various organisms in an ecosystem. So that forms our food web. That is interconnection of food chains in a simple language. Next we discussed about biological magnification or biomagnification. What is this biomagnification? Biomagnification can be defined as the increase in the concentration of toxicants at successive trophic levels. After that we discussed about how we affect the environment and how environment affects us in return. For that we discussed ozone layer and its depletion. So in that we discussed how the ozone acts as a shield for our earth and protects us from the harmful ultraviolet rays of the sun. So how is ozone formed? The O2 molecule will be broken by UV rays into O plus OO. Then one of the O will be combining with the molecular oxygen to form O3. So this is how ozone is formed. And this is very important at higher levels of atmosphere. After ozone layer, then we saw how it is getting depleted. It is because of the CFC production, which was stopped at 1986 levels by an agreement in 1987 by the United Nations Environment Program. After that we discussed what is garbage. The household wastes is commonly referred to as garbage. Then we saw 4 methods of waste management or garbage management. In that first one we saw was recycling. Then we discussed about composting. Then we discussed about landfilling. And finally we discussed about incineration, or can also be called as burning in simple language. Every single type of waste management has its own pros and cons. So based on what is our substance or material or the waste which is there, we can segregate the waste and then process it based on what kind of waste it is. Can it be recycled? Yes, we can send it for recycling. Is it biodegradable? Yes, we can send it for composting. So waste management is completely dependent upon the waste which is being generated. So this is about waste management. This brings us to the end of this entire chapter. Now let us quickly take few questions from the previous years related to this chapter. First question is from food chain. In the following food chain, 20,000 joules of energy was available to the plants. So to the producer level, how much amount of energy was there? 20,000 joules of energy. How much energy would be available to the man in this chain? So man is at which trophic level? At the 3rd trophic level. We know from plants to sheep 10% energy will go, from sheep to man 10% energy will go. Simple calculation, a 1-mark question. A simple technique to do it is just whenever we want to find 10% of something, we just need to divide it by 10. So what we can do here is, for plants how much amount of energy is there? 20,000 joules of energy. So for sheep, 10% of plants, that is 10% of 20,000. A simple method to do is just divide 20,000 by 10. You'll get the answer. 2,000 joules of energy. That is for sheep. Now for man, how we will get? That is 10% of sheep. How to get 10% of sheep? 10% of what is for sheep? 2,000. So we'll get 2,000 by 10, that is 200 joules of energy. So at the 3rd trophic level, or the energy which would be available for the man will be 200 joules. This is the answer. If you want to show the steps, we can show these 3. Next question. In the following food chain, 100 joules of energy is available to the lion. So they are giving us the value for the lion. and here they are asking us how much will be available for the producer. So they are asking us to do the calculation and return. When we were going from plant to lion, we were dividing by 10, divide by 10, divide by 10. So when we are going in reverse, what we will do? We will do into 10 into 10, because same 10% law, 10% law. So we are going now back to the producer level. They are asking us to calculate how much of energy will be there at the producer level. So lion, 100 joules of energy is there. Deer, 10 into 100. What is 10 into 100? 1000 joules of energy will be there at the deer level. When we finally reach plant, again deer into 10. What is deer into 10? 1000 into 10. That is 10,000 joules. So here we will be having 10,000 joules of energy. Very simple calculation. When we are moving from lower trophic level to higher trophic level, the calculation is divide by 10. When we are moving from higher trophic level to lower trophic level, the calculation is multiply by 10. This concept, if it is there in your brain, any calculation is very simple. So this chapter, they might ask simple question based on this 10% law calculation. One more last question we will take from previous years. It is from 2019, 3 marks question. Here it is. They're asking what is a food chain. We already know what is the definition of food chain. The sequential interlinking of organisms involving the transfer of food energy from the producer through a series of organisms that consume and are consumed is referred to as food chain. We can write the definition. Next, design a terrestrial food chain of 4 trophic levels. So they are asking us 4 trophic levels, and they are asking us terrestrial food chain. Terrestrial means we do not have to include any aquatic organisms in this. We can design the same food chain which we discussed in this video: grass, grasshopper, frog, snake. A simple terrestrial food chain we can design. Next part of the question: if a pollutant enters at the producer level, the organisms of which trophic level will have the maximum concentration of the pollutant in their bodies? So the organism which occupies the highest trophic level, for example in a food chain we know 4th trophic level is generally the highest trophic level. So the organism which occupies the highest trophic level will have the highest amount of the pollutants. Pollutant here is what? Nothing but the toxicants. Here pollutants is nothing but the toxicants or the harmful substances for our body. Next, what is this phenomenon called? This phenomenon is called as biological magnification. So they do not ask much tough questions from this chapter, but basically they ask you conceptual questions or some calculation based question like the previous 2 questions. So with this we come to the end of this video as well as this chapter. Thank you so much for watching this video. If you like this video, please hit the like button, share it with your friends, and do subscribe to our YouTube channel.